to calculate the number of molecules in a given mass of the substance. Number of molecules in a given mass of substance can be calculated given mass of the substance in grams divided by gram molecular mass into Avogadro's number. So, let us calculate by taking the example. Calculate the number of molecules of methane in 0.80 gram of methane. The solution molecular formula of methane is CH4. So, let us first of all calculate its molecular mass. Molecular mass of methane is equal to 1 into 12, number of carbon atoms are 1, 12 is atomic mass. So, 1 into 12 plus 4 into 1, 4 is the number of hydrogen and 1 is the atomic mass of hydrogen. So, 12 plus 4 is 16, 16 AMU is the molecular mass of methane. Gram molecular mass of methane is of course 16 grams, and now we will have equation. 16 gram of methane contains 6.023 into 10 raised to power 23 molecules. 1 gram will contain Avogadro's number divided by 16, and then you can calculate in 0.80 gram of methane. So, Avogadro's number divided by 16 into 0.80. So, the number comes out to be 3.01 into 10 raised to power 22 molecules. So, this much number of molecules are present in 0.80 gram of methane. The fifth application is to calculate the volume occupied by given mass of gas at STP. The formula for it is volume occupied by given mass of gas at STP is equal to mass of gas in grams divided by gram molecular mass into 22.4 liters. So, let us take example, calculate the volume occupied by 16 gram of oxygen at STP. So, first of all, molecular mass of oxygen, now you must be quite familiar with this term, it is equal to 32 AMU, its gram molecular mass is 32 gram, and this is equal to 1 mole, and its volume will be 22.4 liters. So, you equate 32 gram of oxygen at STP occupy volume, that is equal to 22.4 liters. 1 gram will occupy 22 upon 32, and 60 gram of oxygen at STP would occupy volume 22.4 upon 32 into 16, this comes out to be 11.2 liters. So, we can say that volume occupied by 16 grams of oxygen at STP is 11.2 liters. So, this is about mole concept. Now, we proceed for the other topic, that is the solution. So, before going for the concentration of the solution, let us have a general look on solution. A solution is a homogeneous mixture of two or more pure substances. Composition of a solution can be varied within certain limits, and solution is obtained by dissolving a solute in a solvent. Solute plus solvent is a solution. Now, what is solute? The substance which is dissolved and is present in lesser quantity is called as solute. The substance in which solute is dissolved and is present in greater quantity is called as solvent. For example, 2 gram of sugar when it is dissolved in 50 ml of water to form a solution, then sugar is solute and water is solvent. Now, we come to methods of expressing concentration of solution. So, first of all you must know what is concentration. The concentration of solution is defined as the amount of solute present in a given quantity of the solution, that how much solute is present in a particular quantity of the solution. So, we have various methods of expressing the concentration of the solution. It can be strength, molarity, molality, mole fraction, normality, mass percentage, volume percentage. So, we will study these one by one. First of all, strength. Strength, it is the amount of solute in grams dissolved per liter of the solution. So, mathematically strength of solution is mass of solute in grams and divided by volume of solution in liters. If A grams of the solute are dissolved, suppose the mass of the solute is A gram and it is present in V ml of the solution, then strength will be equal to A into 1000 upon V, because in formula we have volume of solution in liters. So, if volume is given in ml, so we will have to convert this ml into liters, V upon 1000. So, our equation will be mass of the solute in grams divided by V upon 1000. So, 1000 comes on the numerator. So, A into 1000 upon V. So, this is the strength of the solution. So, units wise strength is in grams per liter, G per L. The second method is molarity. It is designated by capital M. The number of moles of the solute dissolved per liter of the solution is called as molarity. Mathematically, molarity, number of moles of solute dissolved or volume of solution in liters. So, in generally volume is expressed in ml. So, our equation becomes number of moles of solute divided by volume in ml into 1000. So, if number of moles are not given, we are given the mass of the solute. So, we have to convert that mass into number of moles, which you have determined previously also in mole concept. So, number of moles can be calculated from given mass. So, number of moles of solute will be equal to given mass divided by molecular mass. So, putting this value into the formula of molarity, M will be equal to given mass divided by gram molecular mass into 1000 upon V. So, this is the molarity of the solution. As molarity changes with the temperature due to contraction or expansion of the liquids, even then this is the most familiar method of expressing the concentration of the solutions in the laboratories. So, we can have a numerical calculate the molarity of solution containing 0.5 gram of sodium hydroxide dissolved in 500 ml. So, given mass of sodium hydroxide is 0.5 gram, molecular mass of sodium hydroxide is calculated as 40, number of moles of sodium hydroxide given mass divided by molecular mass 0.5 divided by 40, this comes out to be 0.0125. Volume of solution is 500 ml. So, molarity is number of moles of sodium hydroxide into 1000 upon V, number of moles into 1000 upon V is 500. So, molarity of the given solution is 0.025 m. Then the next method is molality, number of moles of solute dissolved per kilogram of the solvent is called as molality. So, molality represented by small m, number of moles of solute divided by mass of solvent in kilograms. If mass is given in grams, so equation becomes mass of number of moles of solute divided by mass of solvent in grams into 1000. If the mass of the solute is A grams and that is dissolved in W grams of the solvent, we will have equation for molality M is equal to A upon molecular mass of solute. This is the number of moles given mass divided by molecular mass into 1000 upon W. So, molality it does not changes with temperature. So, we can have a numerical calculate the molality of an aqueous solution containing 4 gram of urea in 500 gram of water. Given mass of urea is 4 gram, molecular mass of urea 60, mass of water is 500 gram. So, molality is equal to given mass divided by molecular mass into 1000 upon W. Given mass is 4, molecular mass is 60, 1000 upon W is 500. So, result is 0.133 m. So, the next method is mole fraction represented by small x. The ratio of the number of moles of a component to the total number of moles of all the components. For a binary solution, we have only two components, solute and solvent. So, suppose a solution contains Na, small n is the number of moles, A is for the solutes, we have taken as A. So, Na number of moles of solute and Nb moles of solvent, then mole fraction of solute which is represented as Xa will be equal to number of moles of solute Na divided by total number of moles Na plus Nb. Mole fraction of solvent will be equal to Nb upon Na plus Nb. The sum of mole fraction of all the components is always equal to 1. Xa plus Xb will be equal to 1. So, it is a dimensionless property because it is being a ratio. So, we have a numerical here also, a solution containing 23 gram of ethanol in 90 gram of water. So, mole fraction of ethanol and water we have to calculate. So, mass of ethanol is 23 gram, molecular mass is 46. So, number of moles of ethanol they comes out to be 0.5, mass of water is 90, molecular mass of water is 18. So, number of moles of water is 90 upon 18, 5. Total number of moles, that is equal to 5.5. Mole fraction of ethanol, number of moles of ethanol divided by total number of moles, that is 0.09. Mole fraction of water will be equal to 1 minus 0.09, this is equal to 0.91. Then we come to normality, number of moles of gram equivalents of solute dissolved per liter of the solution. So, normality, number of gram equivalents divided by volume of solution in liters. So, if it is in ml, so number of gram equivalents of solute divided by volume in ml into 1000. So, gram equivalents of solute will be equal to mass of solute divided by equivalent mass. So, our equation becomes N is equal to A upon equivalent mass into 1000 upon V. So, like molarity, normality also changes with temperature. The sixth method is mass percentage. It is equal to weight of solute present in 100 gram of the solution. So, mass percent is weight of solute divided by weight of solution into 100. So, weight of solution is weight of solute plus solvent. So, for example, 5% solution of NaCl means 5 gram of NaCl in 100 gram of solution or 95 gram of solvent. So, volume percentage, it is the volume of component present per 100 parts of the volume of the solution. If Va and Vb are the volumes of components A and B, then we can calculate volume percentage of A, volume of A plus divided by volume of A plus volume of B into 100. So, it is expressed as V upon V. So, these are the 7 methods for expressing the concentration of the solution. So, this is all about mole concept and the solution. Thank you.